Hey there! Today let's talk about the journey of a cat and light. So here is a story. One day I was still sleeping and my cat got hungry and she definitely wants food. So this is her. And so I open up my eyes and I see my cat, very cute. And that's the end. But what is happening between we wake up, open our eyes, and the cat? Here is a science story unpacked. So the visible light to human eyes are approximately 400 to 700 nanometers. And if you want a detailed breakdown of the colors and the wavelengths, you could refer to this diagram here. And the light we could see then reflected off of the cat, right? Very cute. And then travels to cornea and the outer layer of our eye. And the cornea then passes through the aqueous humor. And when I'm looking at this diagram and learning about human eye, I thought human eyes are full of humor. We have aqueous humor and we have vitreous humor. And then it's kind of like this light blue curve here that is aqueous humor. Enters the pupil, which is the black center in here, in iris, right? Iris then controls how much light enters into our eye. And also iris is the color of a person's eye. And when we say, you have beautiful blue eyes, you have beautiful brown eyes, you have beautiful green eyes, that refers to iris. And if you remember what we talked about in the human genetics, there is a concept called phenotype, if you remember. If you don't, please go refresh on it. And so iris can dilate. If you look at this cute cat here, the pupils are dilated and then or constrict. So this depends on how much light there is. When it is too dark, there's not enough light. Not only our eyes, but the cat's eyes will dilate. And when there's a lot of light and you don't have sunglasses, we kind of constrict. That's iris. And then the light will pass through lenses. Lenses is kind of like the camera lenses, will accommodate the light based on how much light there is, and it really sharpens the vision. And then it travels through vitreous humor, which is this orange blob here, and it's full of jelly-like water, and it reaches retina. And retina is this pinky orange-ish border that you can see at the back of our eye. And retina has a specialized pit. It's called fovea. Fovea, if you can see the cat, he is very focused on reading the book. Fovea help our eyes to focus. And the cones and the rods in the retina converts the light into action potentials. And this process, and of course there are many cells, like bipolar cells and glial cells within the retina. If you want to dig a bit deeper and see some details, let me know if you want me to make another video. for that level of detail. And so this process of retina converting light into action potentials, if you remember your neuroscience subject about action potentials, the neurons and the fire and the wire and the neurotransmitters, this process is called transduction. And the action potential then transmitted through the optic nerve. And the optic nerve is where the light passes through different brain structures for visual processing. And if you want another video explaining the of how does brain process, which part of brain process the action potentials for our vision, please let me know. I will make a separate video for that. And then that's how we see our cat wake us up. I hope you enjoyed today's video. If you have any feedback, or if you have any area you want me to dive deeper on, please let me know. And of course, if I made any mistakes, please let me know. It will help me to improve the quality and accuracy of my videos, and it will also help other students to learn from high quality sources.